All right, so the first thing we need to do to get a job going is we need to download some files from DMS and also get our plan set. So I'm going to get on DMS here and show you what we need to grab. We're going to work in the Yellowstone Park project on the dig out that we completed last summer. And the project number for that is 8107-000. So there's 3 files we need to grab off DMS. The first one is the RDCRR DGN file. And I'm just going to use Control F to find it. And we got several for this job. These 3 down here are for the dig out we're doing this coming summer. We're going to work on the dig out that we already did. So that's this first one, RDCRR001. So we'll download that. We also need a couple files from survey. We need the survey control file, which is SUCON. And we want the one that ends in .ift. That's this one. That's a text file that contains all of our control points. And we also want the survey README file, which is SURME. And this is just a file kind of describing certain things about the survey that we are going to need to know. So we'll download those 3 files. And looks like we're ready to go. Now, next thing we need to do is create a project directory to work in. So we'll go to the start menu and just type create. And there's the create project directories app. All we have to do is type our project number in here. It's 8107. Now I'm just going to add 111 for training because I already have an 8107-000 on my computer. We'll create project directories. Now we have somewhere to put all our files, keep them organized. Close out of that. And the first thing we need to do with our files is we need to open up OpenRoads so we can extract some data from our DGN file that we just downloaded. So we'll go to construction survey startup. And we want to be in the enhanced workspace for OpenRoads. Then choose Helena as my server since I'm on the VPN. We'll fire it up. While that's going on, we will move the files we just downloaded from DMS into the project folder we just created. So DMS downloads our files into CDGN. We'll go down to 8107, and we want the RDCRR DGN and the SUCON.ift and the SURME. I got a bunch of other stuff in there because we've already been working in this project, but those are the three that we just downloaded that we need to bring with us. So then we'll go to MDT data and projects and 8107.111, which is the project directory we just created. Then we'll go into GPK, which is where we store all our microstation files. I'm just going to paste them all right here. Then I'll move the survey ones into the control folder. And as usual, Bentley's taking forever to launch. And it's finally open. So we'll go ahead and open up our RDCRR file in our 8107.111 folder, GPK. And here's our file. It looks like whoever was working in this file loss was looking at the model in 3D. I'm just going to switch it back to 2D because it's what I'm used to looking at in CAD software. All you have to do to switch between 2D and 3D is click on this models button up here. And you can see we're on default 3D model here. If you double click on default, it'll switch back to your normal 2D wireframe top view that anyone who's been working in CAD is used to seeing. So there's our dig out. And all we're going to do in OpenRoads is we need to extract two pieces of data. We need the existing ground surface, and we need our corridor data. So we're going to extract that two different ways. We'll start with the existing ground surface, which is this. This is a surface here. It's set to only display the boundaries, so you can't see the triangles or contours right now, but we click on it, it says terrain model. And we just need to export it to a land XML so TBC can use it. And if we click on it, this little context menu pops up. And the last choice here is export terrain model. So we'll click on that and do land XML. And for some reason, OpenRoads doesn't remember what surface you had clicked on when it opens up the little box. So you still have to pick it again. It was 8107 RDDTM 001. And we'll just give it our project name. Oops. Project description, Yellowstone Park. That looks good. I keep this on export both. It says you can choose the triangles or the features. I just do both. then you gotta left click out here a few times and it'll ask you where you want to save it. So we'll jump back to our MDT data projects folder and we'll go into 8107.111 GPK and we'll save these in the output folder. Okay, so now we got our existing ground surface ready to go. Now we need to get this corridor data out of OpenRoads. When you guys open up OpenRoads using the Survey English template, it'll probably be on this Survey tab in the task pane. So to get back to the export tool, we want to go to the Civil Tools tab here. It's just one back from Survey. And then we want to go under this Model Interoperability here. What we're going to do is we're going to create an ICM that contains all the data from this corridor in a way that TBC can understand it. Because if you directly import the DGN, it'll just bring in line work and it doesn't understand the intelligent corridor data. So we're going to click on Create ICM here. This is really easy. It only has two options. It says, do you want to include the design models, the terrain models, or both? We only want to do the design models. If we include the terrain models as well, it just makes our drawing more cluttered. So this is the best way to do it, I've found. So we'll do the design models. It's going to ask us where we want to save again. So we'll go back to, C, MDT data, projects, 8107.111, GPK, output, and hit save. So it says down here, ICM repository command finished. So that's done. And we're done working in OpenRoads, so we can close out of that. Now, next thing we're going to do real quick is in our 8107.111 folder, that project directory, we're going to add a folder for TBC. Just so we have somewhere to keep all of our TBC files as we work. Now we'll launch Trimble Business Center. My icon's messed up and it shows this little new document icon, but this is my TBC icon on the bar down here. Okay, so you're gonna start a new project. I don't recommend using this new default project button up on the top toolbar here because it doesn't let you choose which template you're gonna use to start your project. I recommend going over to File here and then going to new. Now we have a list of all of our templates and we can choose which one we want to use. I'm going to use this Crew 2284 construction template that I created. After this training is done, I'm going to send you instructions on how to install that. I have it out on the server with a batch script file, so all you have to do is click on it and it should install it in the right folder. But we'll start a new project with that. The nicest thing about this template is I changed the rounding on all the units, so it should match what's in our spec book. So other than things where you have to convert units, like if you were doing seating, you have to convert to acres because it gives you square yards for area. You should not have to worry about whether it's rounded correctly because it should be good to go if you, for whatever numbers the TBC software spits out, as long as you use this template. Okay, so we have a couple things we need to do to get this project set up properly before we start working. So we'll go to project settings and get that all ready to go. That's this little cog up here on the toolbar. We need to put in our project information so that when we print out reports for volumes and quantities, it'll show up on there. So for the project reference number, I'm going to do 8107-111. For project name, I'm going to use the Federal Highways project number. So now I'll go get the plans off of our server here out of the project file and contract info, so we can see what that project number is. NH 50-14110. Project description will be Yellowstone Park. Company information and company information is all filled out. User information, I've just been leaving blank. It doesn't really show up in any of the reports we print out, so I don't think it's that important for us. One other thing we have to set up is the coordinate system. I left it on the default and didn't change it to anything we might use. The reason I did that is because the coordinate systems on all of our jobs are not necessarily the same, and I want to make sure that everyone goes and looks at the files and make sure they get the right one when they start the project. So set to the default, we're going to change it. And the best place to find out what coordinate system we're using is that survey README file we downloaded earlier. So we're going to go back to our project folder that we created, go into GPK and go into control, and open up that README file. This is where I like to go look for this information because this can come straight from survey. So we know it's got the right information in it. You have to do a little bit of digging, but the important things are we need to know what geoid it's in, and this is 12A. And we need to know what version of state plane coordinates it's in, and here it says NAT 83 2011. So those are the two important pieces of information we need. When you set up the coordinate system, after you've done a few of these, you'll get a bunch in your recently used coordinate system list, which I have several here. I'm going to go through it as if you don't have any of those in there yet, so you know how to do it. So under coordinate system and zone, you want to scroll down to United States. And ITRF to NAT83 is the NAT83 2011. If you had an older project that's in regular NAT83, you'd choose this United States State Plane 1983. Ours is in NAT83 2011, so we'll choose the ITRF to NAT83. And then we'll scroll down to Montana. And hit next. And our geoid was 12A. So we'll go to 12A. Continents is for continental US, so that's the one we want. And we'll call it survey quality. And we'll hit finish. And you can see it put it into the right coordinate system. So now our project settings are good, so we'll hit OK. And you can see Montana 2500 popped up down here on the bottom. So we're in the right coordinate system. Now, before we do anything else and start importing data, we're going to save our file. So we'll go back to the C drive and go to MDT data, projects, 8107111, TBC, and we'll call this 8107111, and we'll hit save. Okay, now we're ready to start importing some of our data. Before we do that, I'm just going to give a little bit of an explanation about some navigation here. We got a pretty normal tool ribbon up here with all kinds of tools we can use for working with our files. But two things we're going to use quite a bit are the Project Explorer and the View Filter Manager over here in this pane on the left. The View Filter Manager allows us to filter by layer. There's several pre-made layers already in this template file. And it also allows us to filter out by object. When we add in, for example, surfaces, it'll list some of them at the bottom here. And we can check and uncheck them to show and hide them. And this just kind of gives us some control over what we can see on our screen. If we choose to check something, we can see it. If we uncheck it, it hides it. It's kind of like the layer manager in OpenRoads, but a little bit more powerful. And Project Explorer will populate all the stuff that's in our drawing: surfaces, corridors, alignments, points, imported files. So it's kind of like it just shows everything that's in there in a list form, so we can look at what we got going on in our file. So let's go ahead and import some of our data. We can either click here on the ribbon under Home, Import, or we can click up here on the toolbar. There's another import icon. Doesn't matter, they do the same thing. And the first thing we need to do is get to the proper folder where our files are. So we'll click on these three dots over here, and we'll go to C, MDT data, projects, 8107111, GPK, output, because that's where we put our surface land XML and our ICM file. So we hit OK, and they both show up in this list. And we're going to import the ICM file first. We're going to leave the existing ground out until we're done building our corridor, because it just clutters up our drawing and makes it a little bit harder to work. So we'll grab our ICM, and we see we have some options for our import down here. It's asking us what data to import. It says civil objects only, component meshes only, or all. We want to do civil objects only. It makes our drawing cleaner. Doesn't bring in as many extra surfaces that we don't need. We're going to import non-corridor line work as line work, not alignments. The reason that's an option is OpenRoads doesn't distinguish between a 3D line string and an alignment. They're the same object, but most other CAD software, including TBC, does. So it's asking us, if your line isn't on the corridor, do you want to have be an alignment or a line? And we want a line because we don't want to have tons of alignments in this project. They'll just get confusing. And then it's asking us what we want to create the surface for the corridor from, the surface mesh or the line strings. We'll choose the line strings. That's more likely to work properly, although either way, we're going to delete it. So we'll go ahead and hit import. And there's our data from OpenRoads. So you can see we got a couple surfaces here and some 3D lines. And we can kind of look at what got brought in over here on our Project Explorer. We still got a bunch of alignments because it'll still turn everything on your corridor top surface into an alignment. So there's still quite a few. We have one corridor. It's called DESN1 because that's what it was called in OpenRoads. And we have several surfaces, and we can kind of see the extent of them in orange here. If we click on them, it's highlighting them in orange. So we got two that basically cover the full extent of the corridor, and these design triangles, one, look like they're pretty much just the road. So let's take a closer look at our corridor. If we expand the DESN1 corridor here, we have a corridor finished surface. That's just the finished top surface of the corridor. And we have this corridor template here. It says 101694. And corridor templates are basically where we store the instructions for the software on how to build our corridor. So we'll take a closer look at our corridor template here. We'll right click on it and hit edit. And now it'll show us our corridor down here in cross-section view on this screen right here. The reason we don't see anything is because 101694 is before the start of the model. We slide the slider up a little bit down here. Now we can see our road. And this screen here is where we're going to do a lot of our work getting everything ready. So the way that the ICM import tool builds these corridors out of the box is it just drapes a surface over the top of the whole thing, and then it drapes another surface over the bottom. So this is how we can edit how our corridor is set up. And right now, all it's doing is TBC automatically created this top and bottom surface, and then it's using those surfaces to define the corridor, which is fine starting out, and it actually works pretty well. Like our super elevation looks like it's working correctly, and it looks like everything came in fine. But we're going to need to basically kind of rebuild our corridor here, because the problem with this is we can't really edit anything. Because the corridor is based on these two surfaces, we can't, for example, change the catch point location at the end of our cut slope here if we want to. Or we can't change this, we can't change the side slope because it's all based on these surfaces that we can't really edit. So what we want to do instead of what TBC has done here is we want to build our corridor based on the 3D lines that came in when we imported our RCM. So what we're going to do is actually just delete these surface instructions out of our corridor definition. So all we have to do is right click on them and hit delete, and it'll remove them. So now we have no instructions in our corridor. We basically have an empty corridor. We can still see those surfaces outlined in gray here because they're referenced in, but they're not actually a part of the corridor anymore. There's basically nothing in it. So we're going to clean up this drawing and get ready to build our corridor based on the line work. So we'll close out of this corridor editor and we'll be back to it again later. And the first thing we're going to do is we're going to get rid of all these surfaces. We're not going to use them, and they're just in our way. So we're going to delete the surfaces. There is a little quirk in how TBC handles surfaces, and that is that even after you delete the surface, the break lines from the surface will remain on the drawing. So before we delete them, we kind of want to take a note of what their name is so we can find the break lines and delete them later. So these surfaces are called design triangles 1, DES on 1 bottom surface, DES on 1 top surface. So we'll just kind of remember that real quick. I'm just going to hold down shift to select all these surfaces, and then we'll right click on them and delete. So they're all gone now. And now we need to clean up those break lines from the surfaces that I was talking about. Like if we click out here, it says there's several break lines from those surfaces still existing on our drawing. We need to get rid of all those. The best way to do that is to go over to our view filter manager. And we can see here under the layers list, there's several layers that have the same name as our surfaces did. And they say boundaries or break lines after their name. That's kind of a dead giveaway that those layers contain our boundaries and break lines from those surfaces. So what we're going to do is we'll hold down shift and select all of these layers. Then I'm going to right click on them and hit view only this. So this is only showing us what's on those 4 layers right now, which is all stuff we want to get rid of. So we can just window across all of this and then right click and delete. So those break lines are all gone now. So we can right click back on the view filter manager and hit view all so we can see everything again. We still have a couple break lines on here. If we click over here, we can see there's a break line from the DES on 1 surface. And in the brackets here, it's telling you what layer it's on. So it's on layer ES terrain contour minor. So we're going to go ahead and isolate that ES terrain contour minor layer. So that's right here. We'll do view only this. We got this kind of boundary from that surface. So we'll window across that as well and delete. And then we'll right click back in our view filter manager and hit view all. And I don't see any other white lines sticking out on my drawing. Usually the break lines are white, so that's kind of a dead giveaway that something might be a break line. But everything on here is gray or some other color. So it looks like all of the break lines are gone. So the next thing I'm going to do is there's this fiber line that the designers brought in, and also this edge of water line that the designers brought in, probably just so they can be aware of where that stuff is while they were working. We don't need them, so we're going to delete them. So now we're kind of down to our line work that's within the corridor here. We're not quite ready to start rebuilding our corridor yet. There's still stuff that needs to be cleaned up from OpenRoads. OpenRoads has a habit of creating duplicate line work at certain locations on the drawing. And we want to clean it up so that we only have one line representing each location at the corridor, because it'll make our job a lot easier when we go to actually build our corridor back up. It's really hard to identify where these duplicate lines are from the top view, because we can see if we click right here, there's 3 lines here, but I don't know if they're at different elevations and we need to keep all 3 of them, or if 2 of them are overlapping and we need to get rid of one. I just can't tell from the top view. So I've found the easiest way to handle this is to go into an actual 3D view. And that's really easy to do in TBC. All we have to do is go up here on the home ribbon and click 3D view. And opened up a 3D view. So now when we pan in 3D instead of 2D. We can rotate our drawing, and now we can see everything in 3D. And this will help us determine if lines are on top of each other or at different elevations, and we need to keep them. So I'm just going to start from the left side of the road and move to the right, kind of working on cleaning this up. First thing I see right away is these purple lines that appear to be hovering over our hinge points. And I'm just going to I highlighted it in orange, but I want to see what the properties of it are. So I'm going to right click and hit properties. We'll open up this properties pane. I just wanted to see what the name and layer of it was. So this one's called EC display rule. And I don't know what these are for, but it has something to do with OpenRoads and must have something to do with plotting the drawing or something. But we don't need them, and they're hovering over our hinge points at a higher elevation, which could confuse us and mess up our drawing. So we're just going to delete that. And I see there's another purple line on this EC display rule layer here on the left or the right. So we'll go ahead and delete that too, just to get it out of the way. Now we'll go back to our left side hinge. It says there's 2 lines here. There's a horizontal alignment and a 3D polyline. Let's zoom out a little bit. so we can see what happens when we highlight each of them. That's the polyline. That's the alignment. Looks like they're both in the same spot and go all the way down the drawing. So if I have a choice between deleting a polyline and deleting an alignment, I'm just going to delete the polyline and keep the alignment. So I just highlighted the polyline, and then I'll delete. So now there's only one line there at the hinge point. Another thing in here that we don't want to keep is we see here a bunch of extra lines start at this station here on the left shoulder. If we click on those, we can see that they're actually the guardrail. OpenRoads actually models the guardrail in 3D, which is kind of cool. If you look at it in OpenRoads when it's all filled in and it looks like a guardrail. But we don't want it. It's not helpful to us for building our corridor in TBC, and it's just going to get in our way. So we want to delete everything on these TL guardrail and TL guardrail post layers. So rather than trying to select all these lines individually, we'll just go back to our view filter manager and find the TL guardrail. And they're right here, TL guardrail and TL guardrail post. Highlight them both. Right click, view only this. Highlight them. Right click and delete. So now all of our guardrail line work is gone. We can right click back into our view filter manager and hit view all. Now we can see all of our other line work again. So now I'm going to rotate this a little bit more. I'm just going to start clicking on these lines and see what happens. If it just highlights it in orange like that, I know there's only one line there. And that's what I want, is to just have one line at each location. So far, so good. And looks like we got two lines at the bottom of the center line here. We got one called TL pavement CAC bottom, and one called TL pavement geotextile bottom. So we're going to look and see if they both span the entire length of the project. CAC bottom goes the whole way. Geotextile bottom goes the whole way. So I'm going to delete the geotextile bottom one and keep the CAC bottom. So now we only have one line at that location. Keep going over here. Right here at our inside edge of our ditch bottom, we have three lines. So we'll zoom back out and take a look at what they do. That one goes all the way. That EC ditch 4 slope that I just clicked on only goes to the end of the cut area. That's not really going to be helpful for us, so we'll go ahead and delete that one. And then the last one also goes all the way down. So we're going to delete the polyline and keep the alignment again like we did on the other side. So we'll delete. Now we only have one line that goes all the way down the project there. And then our outside edge of our ditch looks good. And our catch point lines for cut and fill look good. Okay, so we got this all cleaned up. We only have the line work left that we need. So we can close out of our 3D view now. Go back to our regular plan view. And this is looking pretty good. And we're ready to start working on building our corridor. So we'll go back to the Project Explorer here. And the first thing we need to do is we need to add all of these 3D lines as reference lines in our corridor so that they'll show up in that corridor editor view and we can use them in our corridor. So the way we do that is we'll go over to our Project Explorer under Corridors, and we'll click on we'll right click on DESN1 and hit Edit. And you notice there's no original ground surface in here yet. We're going to leave it like that for now. We will bring it in later. And here we got reference lines. Right now we don't have any. We're going to add all these lines as reference lines. So we're going to click the plus minus button here. I'm just going to click out in space. I got nothing selected. And then I'm going to window across all of this. And it says selected 26. We'll hit add. It says 25 objects were added as reference lines. One object was ignored. The object that was ignored was the center line alignment of our project. That's already in our corridor. That's why I didn't add it again. So that's fine. We'll hit close. And one thing that's very important right here to do is before you hit close, you have to hit apply. If you don't, your reference lines won't get saved. So hit apply, then hit close. So now we're ready to start actually building our corridor. And when we deleted everything out of our template earlier, TBC also just deleted the template, so we have to make a new one. So we'll right click on DESN1 corridor again in the Project Explorer and hit Insert Corridor Template. It's asking us what our beginning station is going to be. So I'm just going to choose it. You can see our alignment starts a little bit before our corridor actually does. I'm just going to pick on the end of one of these lines. Oh, my object snaps. Oh, there they are. So now our corridor template's going to actually start where our line work does instead of at the beginning of the alignment. And we won't have that little gap at the beginning where there's nothing. So it's going to start at 1017 plus a pair. New definition, and we'll just hit insert. And you can see we have a corridor template here now. And it automatically pops up our editor. And I'm just going to close the properties pane so we can have a little bit more space to see what we're doing. I'm going to make this cross-section view a little bit bigger so we can see. And you can see all of those lines that we added as reference lines are shown as a point in cross-section view here. So we can use them to create our corridor. Oops, it looks like we missed a couple that were duplicated at the center line. So let's go ahead and fix that real quick. We'll close back out of our edit corridor template and go back to our 3D view. I'm just going to look at what we had going on in our center line that I missed. Oh yeah, we have a couple duplicate lines there. So this one we have to keep the horizontal centerline alignment. Our whole corridor is based on that, so we can't delete that. This existing ground polyline, I know we want to delete because that's just what design used to kind of follow for their profile and horizontal alignment. But we don't want that because we don't want to accidentally attach something to the existing round alignment and rebuild our bumps. So we're going to delete that. And then we got these two lines here, the design pavement top and the road center line. We want to delete the pavement top because we have to keep the center line alignment. Okay. So now we should be all cleaned up. So we'll exit back out of our 3D view and we'll go back to the Project Explorer and right click on our corridor template and hit edit. That'll bring us back into that template editor view. And we'll expand this back up so you can really see what we're working on here. I'm just going to slide the slider a little bit forward for stationing down here so we're not right at the beginning. Okay, so now we have our lines. We need to start writing instructions telling it how to connect the lines and what type of material is where, basically. So we have a couple things we need to do before we start with that. The first is under this edit corridor template pane on the right, there's this little icon called Manage Material Layers that we want to click on. And we want to set up our material layers so we get the surfaces we need. Basically what this does is for each material layer we define here, we can create a surface out of it. So the main things we want to make sure we have in this list is any surface we need to grade check on, we need a material layer for, and also anything we want to measure by area using our corridor in TBC, we also want to have a material layer for. So for grade checking, we want to have finished grade, mainly just for checking in at the ends when we start slope staking to make sure that our design matches what's out there. We need a top of CAC for grade checking, and we need a subgrade for grade checking. So I'm going to delete these overX strip and bottom layers. They're just kind of defaults. Bottom is redundant with subgrade, so we don't need that. And we'll add one called CAC top. So now we got everything we need for grade checking. We want to go through the plans and kind of think about what we want to measure by area using this corridor. So we're going to kind of just go through and develop a list here by looking at the summary tables and see what this would be useful for. So One thing I see right off the bat is we could use it for chip seal. On this particular project, that's not extremely useful because the chip seal is way longer than the dig out, but just for the sake of showing you guys how to do it, I'm going to include the chip seal. So we'll have a chip seal material layer. Let's see, aggregate treatment, that's a good one. We can do an aggregate treatment material layer. That'll give us an area for that. TAC is measured by the gallons. That's not helpful. We won't do that. Let's see. Geotextile. Geotextile we can measure by area. So we'll do a geotextile material layer. And we can also do seeding. So on this project, we have seed, mulch, and conditioned seed bed, all as items. The seed and the mulch are going to be the same area because they both get spread over the same area. So we're going to create one surface for measuring both of those. So we'll call it seeding and mulch. Conditioned seed bed only happens on slopes of less than 2 to 1. And we have a big side slope that's 2 to 1. So we'll make conditioned seed bed a separate material layer. So we'll go back to TBC and create those layers. We'll have ag treatment, chip seal, geotextile, seeding and mulch, and condition seed bed. And that should cover all of the materials that we want to measure by area using our corridor. It is fairly easy to go back and add one later if you decide you need another one. So it's not a huge deal if you forget something here. And we'll hit close. You can see in this material layers list here, now we have all these layers that we just created. The other thing we want to check real quick is we have another method of measuring by volume, and that involves this material above drop-down menu. So under surfaces here on the ribbon, we want to go to MSI Manager. And we just want to make sure we have a material to use for everything we want to measure by volume. And there is default materials included already in the TBC template. So if we expand materials here and we go under earth and select, we have hot mix asphalt and aggregate base as materials in the MSI Manager. And that's all we need for this job. We don't have any special borrow. If we did have special borrow, I'd probably just use this aggregate sub base. But we just want to make sure that they're here. Sometimes I've had problems with MSI Manager where it doesn't import the materials properly. And if that happens, you can create your own materials pretty easily. If you just right click here, you can do a new asphalt material, for example. So it's not too hard to create new materials if you have some problems and this doesn't show up. But I always like to make sure before I start building my corridor that this is working properly and I have the materials I need. So We can close out of the MSI manager now. And we're ready to actually start building our corridor with instructions. So we'll start from the center line first on the top and head to the left, and then we'll head back to the right. So the first one we're going to do is we're going to go from DSN1, our top center line, to the edge of shoulder, which is this 23, DSN1, left edge of shoulder top. And we need to pick the type of instruction we're going to use here. And we're going to use a connect instruction because we're just connecting two existing points. So it's just asking us what node we're going to start at and what node we're going to end at. We're going to start at the center line, number 1. We're going to end at 23. Now we want to choose the material layers that this line is going to represent. It's going to be finish grade because we're on the top. It's also going to be chip seal because we're on the top of the pavement. And that's going to be it. And we're not going to have any material above because we're on the top surface. So we'll hit add. And you can see it created this line here at a 2% grade. That looks good. And if we go up at our plan view, we can see the surface triangulated here between the center line and the shoulder. And the reason that is because under our corridor DSN1, we have this DSN1 finish surface. So anytime we add a line and have the finish material layer checked, it's going to triangulate the surface in between those two lines. So it's going to keep building as we build the finished surface here. So next we'll go from the edge of shoulder to the edge of pavement, and that's from 23 to 19 here. So we'll go 23 to 19. That's still finish and chip seal, when we'll hit add. Now we're going from 19 to 11. This is like the slough of our pavement here. So 19 to 11. And we'll uncheck chip seal because we don't pay them to chip seal the slough. Hit add. So now our top of pavement surface is kind of built out from center line to the left edge. Normally we would connect from here down to the hinge, but the design of this road is kind of unique, and I'll show you what I mean in the cross sections here. This hinge edge point of our prism is actually our catch point. You can see here it's just catching out at the edge of the existing slope here, and it does that through all the cross sections. See how it widens out here to match. So what we want prior to slope staking in the field is we want everything except our catch point modeled. So we're not actually going to include this point out here because that's our catch point. What we're going to do is, after this model is built out to just short of the catch point, we'll go out in the field and stake the catch points, and then we'll come back, bring those points in, and use the points we actually staked in the field to build our catch in our model. And that'll give us the most accurate dirt work volumes. So that's as far as we're going to go on the left side. We'll start building back to the right. So we'll go from 0.1 to 0.20, which is the edge of shoulder on the right. And we're finish grade and chip seal again. Hit add. We'll go from 20 to 22, which is our edge of pavement. (22 to 12), which is our slough again. So we'll uncheck chip seal again. Hit add. Now on this side, our hinge point is out here at the edge of the ditch. So we're going to build all the way out to the outside edge of the ditch. So we'll go from 12 to 24, which is from our pavement slough to our inside edge of our ditch bottom. 12 to 24. And we're going to keep finish grade. This is also going to be CAC top, because if we look at our typical section, we find the right one. Oh. This whole area down here is CAC, including underneath this little slope here. So it's CAC top. We don't aggregate treat the side slope, so we'll leave that one out. It's also going to be seeding and mulch.
Wouldn't that be CAC bottom or subgrade?
No, subgrade's down here.
I guess it's top and bottom because it's on a, it just comes to a point.
Not here, it isn't. The next one it will be. You'll see as we go.
Okay.
It's also going to be conditioned seed bed because this area will get seeded. So we'll hit add. Now we're going to do the ditch bottom, which is from 24 to 21. This one, like Paul said, is both the finish grade and the subgrade, because it is the top surface of the ditch and is also the bottom surface of the ditch. We don't have any CAC going underneath that or anything like that. So it's finish grade and subgrade. There's no CAC here, so I'll uncheck CAC top. And we keep seeding and mulch and conditioned seed bed. And we hit add. Whoops, forgot to choose my 21 node. There we go. Okay. So now we're built out to our right side hinge point. The next thing we'll do is we'll build our top of CAC surface in here. We'll start from the center and go left and then right again. Starts at this 0.5, design center line bottom, which is the bottom of pavement, top of CAC. So we'll start at 5. We're going to go to 13, which is the edge of shoulder bottom. This one will be not finish grade, not subgrade, but CAC top, and also ag treatment. We'll get rid of seeding and mulch and conditioned seed bed. Now here's where we'll start to use our material above drop down. So now we're building this line here. Our material above is going to be hot mix asphalt, because that's what's going to be above this line. So we'll hit add. And you can see it shaded that area in blue. That blue is basically telling us the software is recognizing that we said there's asphalt in there. So it's saying there's a material in here that has a volume that we're going to measure. So we'll go from 13 to 8 next. Just moving over. Our material layers are the same. You know anything about the material above menu is that it resets to undefined every time you do one of these. So you have to select your material again every time. So select hot mix asphalt. Then we'll go from 8 to 11, which is the edge of our pavement slough. Hot mix asphalt, add. So that's finished out to the pavement slough on the right or left. Now we'll go to the right. 5 to 14. Same materials. (14 to 9). And 9 to 12. Okay, so now our top of CAC is all built out under the pavement here. You can see we got our blue pavement volume all built out and enclosed. So now we'll work on building our subgrade underneath the road here. Now I'll start at 0.6 here at the center line, and I'll head to the left again. So we'll go from 6 to 16. And this will be subgrade. And it will also be geotextile. We have geotextile under this road. We look at the typical, it goes from one pavement slough to the other. So we have subgrade and geotextile. Our material above is going to be aggregate base. This is our CAC. We'll hit add. You can see it's shading the CAC orange. Next, we'll go from 16 to 15 with the same thing.
Quick question for you, Chad.
Yeah, what's up?
Does it make any difference if you go from like left to right or right to left, or is it just figured out the same? Like your from and to nodes if you reverse those?
What I've always been told is to build from the center line out. I think there's certain things where it will matter. I don't think it really matters much with this connect command, but I think that keeps everything well organized and easy to understand, basically is what I've been told.
Makes sense.
I think it might help with the calculations too. I think the software might calculate it better that way, rather than if you have lines going different directions towards each other. But that's just, I don't know. I'm just kind of spitballing here as to why I've been told to do it that way. But so next we'll go 16 to 15. Aggregate base above. And then 15 to 7. And you see this is our geotextile line here. This is the end of our geotextile. So if we were going from 7 to 2, we would not include our geotextile anymore. But we're going to stop here because of the whole hinge point thing I was talking about earlier anyways. Aggregate base, add. 6 to 18 on the right. Same layers. (18 to 17). (17 to 10). And this is the other edge of our geotextile. And then we need to finish it out here from 10 to 24. This area does not have geotextile, so we'll uncheck geotextile. And Paul, this is our subgrade through here. Okay. So now we have everything built except for our lines that would go out to our catch points here and way up here. And if we use the slider bar down here on the bottom, we can kind of scroll through and see our supers appears to be working properly. So this is ready for slope staking now. So we can hit close. And now we need to work on exporting the stuff we need to go out and slope stake. So let's go back into our corridor editor for a second so we can talk about what we need to slope stake this job specifically. Normally, and it would work on the right, all you would need to slope stake is your finish grade surface, because that will include everything out to this point, which is our hinge point. However, this job's a little bit unique in that on this side, what we need to slope stake is actually this point down here on the bottom on our subgrade. And the reason for that is if we look at our cross sections again, or even our typical section, we can see it. So over here, it's telling us we need a 0.5% cross slope of the CAC draining to the left, and that this side slope will vary. The reason the designers did that is they wanted to promote drainage to the left only on this road, because we got Gallatin River over here. Over here, there's not really anywhere for the water to go. On the right, it'll just pool up and create more drainage problems, which is what originally caused this road to have giant bumps in it. So our controlling point for doing slope staking isn't here, because this slope's going to vary to meet this catch point. It's actually here on the subgrade, and we're going to have to slope stake out at 0.5% from here to wherever it catches on the existing slope.
And you could probably actually catch to any point on the subgrade because it's all a constant 0.5%, correct?
Correct. You really could. You could in fact catch to this point if you wanted to, but yeah, you could even catch to the center line subgrade. You could catch to any point along this 0.5% line. But the bottom line is, in order to do that, we're going to need to export the subgrade surface as well. Whereas normally you could just go off the finished grade surface. So in order to export the subgrade surface, we first need to create it. We don't have a subgrade surface yet. So we'll go up to the corridors tab on the ribbon. And we have this command here under corridor called corridor surface. It's really easy. All it does is ask you what corridor and what material layer do you want to create a surface for? And you can see all the material layers we created earlier are in this list. So we already have one for finish. We can see that over here in the Project Explorer. We'll create one for subgrade as well and hit OK. You can see subgrade popped up here. And we can close out of the corridor editor. And we'll just click on it and make sure its extents are what we expect. And it looks like it is. It's going all the way from this hinge to this hinge. Same with the finish. So those both look good. We're happy with those surfaces. So now we need to export them into something the data collector can use. So we'll go up to the export button here on the toolbar. And there's several different choices, filters here for different file exports. One we want to use is under corridor here. We want to use Trimble Access Road RXL templates. So it's going to ask us what road we want to do, what corridor surface we want to export. We'll start with the subgrade. We can leave the beginning and ending station alone because we want to do the whole thing. We're going to change the name to something that's a little bit more descriptive. We'll call it 8107 subgrade. We want the most recent file version. Template generate method, we'll keep on a corridor interval. It's asking us for the horizontal alignment station interval. So basically what this does is when you're working on the data collector, there's a button that says next. And when you're slope staking, that next button will send you ahead on the alignment, however far you pick here. So what you want to do is you want to select the station interval to be the interval of whatever you think you're going to slope stake at. So for this job, we're going to do 50 feet. It'll just make your life easier when you're staking to set this up the way you want it. You can override it too in the data collector, but this will just make it so it defaults to 50 feet every time, and it'll make it easy for you to work. So we'll hit export. Now we'll do it again with the finish grade. Once again, we'll give it a little bit more descriptive of a name. Finish. Hit export. So now we have our two roads exported, our subgrade road and our finish grade road. One other thing we need to do before we can get set up to slope stake in the data collector is we need to get our survey control into a format that the data collector can understand as well. And what we're going to use to do that is Excel. And we'll open our survey control.ift file in Notepad. And the only thing we want to bring into Excel is the point, northing, easting, and elevation. we don't want any of this other data to come into our file because that'll just confuse the data collector. So we're going to highlight all of our control points and just hit copy. And I noticed two things as I was highlighting that are going to cause problems, but we'll deal with them in Excel. This asterisk we don't want in there. We don't want any special characters in our northern, eastern, or elevation. And the space in this name for this control point will also cause problems. But we're just going to go ahead and paste that into the first cell in Excel. And now we'll scroll down and find those ones that had, there's the asterisk, we need to delete that. And then the one that had a space in the name, we'll just remove the space. Okay. Then we'll select all. And we'll go to data and text to columns. And we'll tell this is a delimited file. And we'll say it's space delimited. That's why we need to remove the space from that name, because it would have thought it was another column of data. And you can see it's splitting out our point name, northern, easting, elevation, like we want it to. We'll hit finish. Now we got those in 4 separate columns. So we'll go to File, Save As. We're going to save that into our control folder in our project. So we'll go back to C, MDT data, projects, 8107.111, GPK, control. And we're going to save this as a CSV file. And we'll call it 8107 control.csv. Hit save, close. And now we'll move our files onto our flash drive so we can put them on the data collector. So I'm just going to open up another Windows Explorer here and go to my flash drive. We'll copy this control over. And we'll go back to our TBC folder. This is our TBC file here, this .bce. In this 8107.111 folder is where it stores all the other files that we're using and that we've output. So this 8107 finish and 8107 subgrade here are .rxl are our 2 files that we just exported. So we'll copy those over to our flash drive as well. I already have some because I did a practice of this presentation, so I'll just replace them. And we can just save our drawing and close it. And we're ready to get everything set up on the data collector for slope staking. So I think I'll take a 15-ish minute break now. We'll come back at 9:20 and work on the data collector then to get everything set up for slope staking. So I'm going to use the slope staking file that we did this past spring. So we'll go back into TBC. And I'm going to bring in that data collector file from slope staking. This one's from Survey Pro. So it might look a little different, but it should be pretty much the same as bringing one in from Trimble Access. It says the coordinate systems are different. I don't think they are, but it might be some issue with Survey Pro. I'm just going to click keep the existing project definition and hit OK. I'm going to look at the warnings. I always do just in case it's something bad. It usually is nothing. Oh, it's just telling us about their coordinate systems. So we can see it brought in our data from the GPS. It also brought in our control points. That's why I didn't bother adding them to the file earlier. We can see we set up on this point. And all of these flags here are points that we slope staked. And I'm just going to take a look at them and make sure they're reasonably close. I mean, being off even a few feet isn't out of the ordinary, I'd say, especially with such a big cut slope. So all these look reasonably close to what design did for us. So that's good. So now we'll work on making some 3D lines that connect these catch point lines so we can use them to finish out our corridor in TBC. The first thing I'm going to do, just to get them out of the way, is I'm going to delete our catch lines from the designers. The only reason I really kept them around was just to compare them to our slope staking, but we're not actually going to use them to build our corridor, so we're going to go ahead and get them out of here now. All right. So next thing I'm going to do is make sure my object snaps are correctly set up. So I'm going to click down here where it says snap on the bottom bar. I just need to make sure that the point snap is turned on so that when I'm going to build this polyline, I'm going to snap, or line string they call it in TBC. I'm going to snap to each of these points when my cursor gets close to them, and it'll automatically connect the line to them. So point is checked, it's turned on, so we're good. Hit OK. So we'll go into CAD up here on the ribbon, and we're going to create a line string. So I'll just click right here. And we want to give it a name because that'll show up in our corridor template editor. So we'll call this one catch right. We'll put it on an appropriate layer. So we'll go under road. We'll call it, let's call it corridor model limits, because this is going to be the outer edge of our corridor model. We'll hit OK. Now we're into this window for creating the actual line string. We don't need to mess with any of this stuff. We can just click on the screen to create the line string. So we'll start from this first point here. And this little purple number here is our elevation. So we can see it's giving us a XYZ coordinate when we click on these points. And we'll just draw a line in between them going down the edge here. Make sure you don't miss any, because I've found it's difficult to go back and add one that you've missed. Sorry if it cut out there. My VPN did that dumb thing where it hiccups and takes forever to get back online. So here we have a cut fill transition. This is the end of our ditch. We have a point here. If we connect directly to this point, we're going to cross over our ditch bottom, which we don't want to do. So if you have a situation like this where connecting two of the points together would cross over some of your existing geometry, instead of doing that, go out to the corner of your ditch and connect it there. So we'll just connect to this point. Then we'll connect to our next slope stake catch point. And that'll keep us from having crossing geometry, which will mess up our surfaces. We'll just keep going down the fill slope here. And that's our last point. So we can come down and hit close. So our right side catch is created. Now we'll go back in and do another line string. And this one will be catch left. And this one will go quicker because on this side of the road, we staked at 100-foot intervals because the geometry varies a lot less. We're not up on that big hill above the road. We'll hit close. So now our two catch lines are created. We need to add them as reference lines in our corridor so we can use them. So we'll go back over to Project Explorer, right click on our corridor and hit edit. And we'll go into reference lines plus minus, click out here. And then we'll select our two lines. We'll just hold down Control and click on the other one to select them both at the same time. Hit add. Two objects were added. Hit close. Make sure to hit apply again. Then hit close again. Now we can go back into our template editor. So we'll right click on the corridor template and hit edit. And we'll adjust our views here again so we can really look at the cross section. There we go. Now, right at the beginning, we don't quite have our catches, but if we move forward even a foot or two, now we can see our catch left over here and our catch right over here. So we need to connect those. So we'll go up onto the edit corridor template here and hit add instruction. And we'll start with this left side first. We'll go from 8 to 22. That'll be the top of our slope here. And that'll be finish grade. CAC top, because our CAC goes all the way out to here. Seeding and mulch and conditioned seed bed, because that'll also get seeded. No material above, so we'll hit add. And then we'll go from 4 to 22 for our subgrade. And that'll be subgrade. And that's it. And our material above will be aggregate base. And we'll hit add. So now if we use our scroll bar down at the bottom to scroll through our stationing, we can see that that left side is all looking the way that it should. So we'll work on the right side. The right side will go from 18, which is our outside ditch bottom, to 23. And we will use finish grade and subgrade because it's both the top and bottom surface. And we'll have seeding and mulch, but because this is a 2-to-1 slope, no conditioned seed bed, no material above. We'll hit add. So now we see we got our 2-to-1 slope to the catch point over here. Everything looks good at this station, but as we scroll along, we see that when we transition to a fill, we're not connecting to our catch point. Reason for that is we connected 18 to 23, which is our outside edge of our ditch bottom, but that point doesn't exist when we get into a fill. So we need to connect this 21 to 23, but we only want to do it where there's a fill. We don't want to do it where there's a ditch, because if we connect 21 to 23 here, it's going to go over the top of our ditch and it's going to mess up our volumes. So we need to have a way to only connect 21 to 23 in this area up here where we're going to fill. So I figured out a workaround for this. And what we're going to do is we're going to create another line next to 21, just where we have a fill. So we need to add another instruction, but instead of using the connect instruction for this one, we're going to use offset slope. There's a bunch of different types of instructions you can use in here. Mainly you'll be using them if you need to build a road from scratch. If you get one that's, for example, done in GeoPack where you can't bring in the 3D line work. But the offset slope one is useful for building this extra line to connect to that we're only going to have in our fill slopes. So what we want to offset from is we want to offset from this 0.21. And we want to make this line as close as possible to 0.21, but the software won't let us put it right on top of it. So what we're going to do instead is we will do a slope of 0. And our offset will be just 100th. That's the smallest distance away we can go. However, we only want it to exist where we're in fill. So the trick to do that is under offset, we can take this drop-down menu and we have several choices for how to define our offset. And the way we're going to do it is with a table. A table allows us to vary the offset distance depending on the station that we're at. So we'll click on these 3 dots over here, which will open up the table. And the trick with this is we'll start at the beginning of our corridor here. And for our offset, we can actually leave it undefined by putting in a question mark. So when we do that, that line, the line that we're creating basically won't exist wherever we put in a question mark. So starting at 1017, we're saying offset of question mark. We won't have any, this line won't exist from 1017 until we tell it otherwise. So we're going to go down to our cut fill transition here. Now I'm just going to use the snap here to select the exact station of our cut fill transition. So at that station, we will sell it to offset 100th. So now, up until that point, we will have offset undefined, which means it'll have no line at all. But then after this point, we'll have an offset of 100th. So the line will pop up 100th away from 0.21, so right about there. So we'll hit OK, and we'll name it fill right. And this one will also be finish and subgrade and seeding and mulch and conditioned seed bed. It might seem kind of silly to put these in for something that's only 100th wide, but if we don't, we're going to have a gap in our surface, which could cause calculation issues. So it's better to just go ahead and do it. We have no material above, and we'll hit add. Now, if we scroll in where we can actually see this, we can see that where we're in fill here, we have this little fill right that we added. But if we go back to where there's a ditch, it disappears. And then we'll go up to where there's a fill, and it appears. And the nice thing is if you had a larger project with multiple cut fill transitions, you can just add more question marks and 0.01s to that table that we built. And you can cover all your cut fill transitions with one instruction. So that one was numbered by the software as number 24. So we're going to connect 24 to 23. And you'll see that right now we don't have any surface in our fill area here. But when we connect 24 to 23, it'll fill it in for us. That's still going to be finished, subgrade, seeding and mulch, and conditioned seed bed. And we'll hit add. And it filled it in for us. So now, if we go look at this whole corridor, we'll see that everything is kind of working the way we expect it to as we scroll through. So that's good. Our corridor is ready to go for computing quantities now. So we can close out of the corridor template editor. And what we need to do is create the rest of the surfaces for all of the items we want to calculate. The reason we didn't do this earlier is the more surfaces we have that are based on our corridor, the slower the software is going to recalculate every time we do something in that template editor. So we want to do this as late as possible. So we're not sitting around waiting for everything to recalculate every time we change something. So now we'll go back to surfaces up on the ribbon, or corridors, and do corridor surface. We already have finish and subgrade. So we'll do CAC top. Now we have everything we need to grade check. So we can export that CAC top as a Trimble Access Rodar cell template, just like we did with finish and subgrade. So we'll change the name to CAC top and export. And we can see if we click on it, this is the extent that we would expect it to be for CAC top. So our surface looked good. And now we can create all the ones that we were going to use to measure quantities. So we'll go to corridor surface again. We'll do egg treatment. Chip seal. Geotextile. Seeding and mulch. And finally, conditioned seed bed. There it is. So then we got all our surfaces listed under our corridor here. We can kind of click through them and make sure that they're including in orange the areas that we expected them to. So like conditioned seedbed, we got everything except the 2-to-1 slope that's outside the pavement. That looks good. Seed and mulch is the same thing, but includes the 2-to-1 slope. Geotextile goes from pavement edge to pavement edge. That looks good. Chip seal is a little bit narrower because it doesn't include the sloughs. That looks good. Ag treatment is once again out to the edge of the sloughs. So it's basically the same width as geotextile. So that looks good. So all of our surfaces for quantity measurements look good. So we can use them to generate quantities now. So I'll just use one of them to show you an example of doing that. So if we go to the surfaces tab on the ribbon and go to surface info report up here, we'll just use ag treatment because it's already selected. And then hit OK. It'll generate a report that'll give us a bunch of information about this surface. Most importantly, it'll give us the areas, but it'll give us a bunch of other stuff too. So here's our surface report. And the most important information on here for us is the planimetric surface area and the actual. So these will almost always be different unless your surface is totally flat. For most of our bid items, you're going to use the planimetric surface area as your pay quantity. Some will use the actual surface area though, especially for sure seeding and conditioned seedbed use this actual surface area, which takes into account the slopes. So this will always be a bigger number than this. And it's only used on specific bid items where we measure the slope distance for paying, and seeding happens to be one of those. So you take this number and convert it into acres for seeding. But most bid items, you're going to use planimetric surface area, which is this top one. There's a bunch of other information about the surface in here. And up here on the top toolbar, we can export it as a PDF. We can save this wherever we want. We can save it in the bid item doc folder in our project folders. We can attach it to a bid pay item in Ashtoware and use it instead of the templates if we're calculating something in TBC like this. So that's how you use these surfaces to calculate area. Now I'll show you how we get the volumes out of this corridor. So if we go under corridors, there's something over here under reports called corridor earthwork report. And if we click on that, it'll ask us what corridor, what station increment. So basically this is an end area formula, and it'll calculate your end areas at any interval you ask it to. I think 5 feet's pretty good. If you just want something quick, you could do it at a farther apart interval. If you, for some reason, needed something super precise, you could go even closer. We're not going to do a subsection, although this could be a nice feature on a larger job. If, let's say, you have a contractor that's working on a 6-mile reconstruct, and they've done from station A to station B, you could only include those stations, and it's going to calculate your earthwork for that area. So you can easily do a progress payment for an estimate using that. But this is a little dig out, so we're just going to want to calculate the entire quantity at once. Clipping boundaries you could also use. You'd have to draw one out on here, but similarly, if you had a big project and they'd only finished half of it and you wanted to try to do a progress payment, you could draw a line down the center line and then close it as a polygon on the left or right side of the road and use that as a clipping boundary and use that also to calculate partial payments. So we have some options we can use in certain situations to do that and only calculate the earthwork on part of the project if we need to. I keep all these calculation options checked. And we want the concise report, so that looks good. We'll hit OK. Oh, yeah, we forgot to bring in our existing ground surface. Of course, you can't calculate it without an existing ground surface. So we'll go ahead and add that. So we'll go back to the import tool. And we just need to bring in our RDDTM file, our land XML. We'll import. And this is going to pop up saying there's multiple definitions for the surface data. I always choose both to keep both in an import. So there's our existing ground surface. I'm going to go into the view filter manager and hide it because it just kind of takes over the whole drawing. So under surfaces here, I can uncheck these two 8107 RDDTMs. That should hide most of it. You can still see the break lines and points, but so we need to go back to our corridor, right click on it and hit edit. And we need to select our RDDTM surface as our original ground. And then hit apply. This is where I was saying if you add all these surfaces, it takes forever to recalculate the corridor. And then hit close. Now we can do our corridor earthwork report. We'll get rid of this clipping boundary that's somehow selected. Then hit OK. This takes a little while. It'll pop up our report window again. This one's a little bit longer, so it takes a while to load. So this is our corridor earthwork report. It'll actually give us in here all the end area calculations, but all the stuff that's important to us is on this page 2 pretty much here. So if we go back to page 1, we can see that the heading for this is cut quantities. It gets cut off onto the second page, but This right here is our unclassified excavation number, 20,505.75. If we go back to our plans, we can compare that to make sure we're close. And we got 20,705 in the original plans. That's pretty close because we changed the catch points when we brought in our ones that we staked in the field. So it's never going to be exactly the same, but we're only off by about 200, which is 1%. That's pretty good. Hot mix asphalt, it gives us a volume, but that's not really important to us because we measure hot mix by tonnage produced. Aggregate base, though, this number we can use to pay for our CAC. We got 5632.58. And in the plans, we have 5634. That's pretty much always going to be really, really close. Or it should be. If it's way off, you probably have a problem with your corridor. So those are the important numbers to us off of this. And this is a long report. It gives you every end area. It can be used to generate a mass haul diagram too. And just like the other one, you can export it. It's grayed out right now because it's still generating. This is a really long report, so it takes a while to generate. You can see the page numbers up here are still increasing. It's not done. But when it is done, it will let you export it to a PDF. And then just like the surface areas, you could use it to, you could save it to our bit.mdoc folder or use it in Ashtoware as an attachment. And that's about all I had for you guys. Do you guys have any questions about any of this? I know it's a lot to go through in one morning.
So if I have questions, I know where to find you.
Sounds good.
You talked about payment of surfaces, areas,
Yeah.
and planometric versus actual, I think it was called,
Yeah.
surfaces. But I think generally we want to pay actual surfaces, don't we? I'm trying to think of some bid items, for example, chip seal.
I think that we pay planometric, don't we?
No, I mean, I think the way the spec book is interpreted is we're paying the dimensions, and if we were to measure them off our off of our typical sections, that would be like planometric.
Yeah, but if we go out and measure it in the field, we just stretch tape across the road. We don't take into consideration there's a 2% slope on there.
Right. That's what I was thinking. Because like it's the same thing if we're working off of what they give us from.
Well, it'd be very, very close, but if we have the tape just laying on the ground, it would be the actual because the tape would go up to the crown of the road and then down the other side. So.
Yeah.
Right, but if we use our distance mirror to drive down the road, that's in grid.
Well, that'd be one dimension. So if we're paying for area, that's one dimension. The other dimension would be the
Right,
width.
but if I multiply it by the width in the cross sections, then it would be planometric, right? Those dimensions are measured horizontally, not slope distance.
Yeah, they don't take into consideration slope.
Yeah. Yeah, that's a good point. I mean, they're very close.
Yeah, you're talking about 2% for 12 feet one way.
So I don't know. Either one would probably be acceptable. I'm not sure that it for seating, it's imperative that you use the planometric.
Yeah.
Because slopes make a big difference when it's 6-to-1 slopes or 2-to-1 slopes.
Right, that's the thing is unless you have a steep slope in your area, it's not going to make a huge difference.
Right. Right. But I would say either one's probably fine to use.
Okay.
I'm
I
guessing,
think the way that like MicroStation or AutoCAD would calculate it would be planimetric. I'm just
Yeah.
thinking about how the softwares work.
I'm curious. I'd be curious to do it and to compare it to what our design, what's in the summaries, and see how our designers are coming up with their quantities.
Because if they calculate it based on station times width, that is planimetric for sure. Because stationing runs horizontally, it doesn't follow the slopes.
Right. Yep, good point. All right. Well, thank you, Chad.
Yep.
You're gonna post this recording, you said?
Yeah. I missed the part where we worked on the data collector by accident, but the rest of it I got.
Okay. All righty. Well, thank you very
Thanks,
much.
Chad.
All right. I'll talk to you guys later.
All right.
Chad?
See ya.